Good day. So today I'm going to show you how to deal with fractions in trigonometry. So trigonometry is in two parts. The first part is the changing part. I'll explain what I mean. And the second part is basic mathematics rules. So if you know those two, you will hit trigonometry. So what kills people in trigonometry is those two parts. First is the changing part, second is the basic math rules. So if somebody is good in the changing part, they might not be good in the basic math rules. Or somebody knows how to change things, but they're not good in the basic math rules. So it's those two things that kills people in trig. Once you know those two things, you can do anything you want in trig, you'll still end up at the answer. So what do I mean by the changing part? For instance, you should know that 1 minus cos squared x or theta is sine theta, or the fact that sine theta over cos theta or sine x over cos x is tan x. So the changing part, when you memorize these kind of things, you don't memorize them only one way, right? You memorize, you know that 1 minus cos squared theta is sine squared theta, and sine squared theta is also the same as 1 minus cos squared theta. So you should know how to change them in two ways. You should know how to change from this to this and from this backwards. Or the fact that sine x over cos x is tan x, and also the fact that you can change tan x into sine x over cos x. So we don't memorize them in one direction, you have to memorize them in both directions. So first of all, I want you to pause the video and memorize this stuff. So here we're dealing with the changing part, right? You should be able to know that sine squared theta plus cos squared theta is equals to 1. And also 1 minus cos theta or x is the same as sine squared x. 1 minus cos squared x is the same as sine squared x. Or 1 minus sine squared x is the same as cos squared x, and sine x over cos x is tan x. Also sine squared x over cos squared x is tan squared x. So notice 1 minus cos squared x is sine squared x, but 1 minus cos x is not sine x, right? It only works with the squared version of it. 1 minus cos squared x is sine squared x. So just pause the video and memorize this. So before we deal with this question and various questions that are coming, now that we have fixed the changing part, let's also fix the basic math rules. So we'll look at those rules, then we'll come back to this stuff. Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvement. So once you know those rules, this stuff will become easy. So the basic rules are simple. Do we know how to add fractions? Do we know addition of fractions? Do we know subtraction of fractions? Do we know multiplication of fractions? And do we know division of fractions? So let's just deal with this ones first. Then we will go back to proving the identities and so also simplifying trigonometric functions that have got fractions. So the rules of addition and subtraction of fractions are very simple. If the denominator is the same, let's just say we've got 2 over 3 plus 4 over 3. So if the denominator is the same, all you have to do is that you just keep it as 1 and you add the numerators. It's that simple. This is the same for addition and subtraction. So for instance, if we have something like maybe 7 over 4 minus 3 over 4, since the denominators are the same, you just say 4 and then you say 7 minus 3. You just subtract the numerators, right? So this is also going to be applied in trigonometry. Just remember this first rule. Now, what if the denominators are not the same? If the denominators are not the same, let's just say, for instance, we've got 2 over 3 plus 4 over 5. Please remember this. It's also going to apply in trigonometry. It comes out a lot, right? So what if we have 2 over 3 plus 4 over 5? Whenever the denominators are not the same, what you do is that we will call it the butterfly method, where you multiply the denominators. So 3 times 5 is 15. Then all you do is just cross, right? So you will say 2 times 5, which is 10. And then, of course, the sign there's plus. So then we say 4 times 3, which is 12, right? So we just add them, right? So first we multiply the denominators, and then after that we cross. Now notice we start with the numerator that comes first, right? Notice I didn't start with 4 times 3. I started with 2 times 5. This is very important because of subtraction. So let me just show you the example with subtraction. Here's an example for subtraction. So the rules for addition and subtractions are exactly the same. So what if we have 5 over 3 minus 1 over 2? You just multiply the denominators, and that is 6. Then notice I'm going to start with this one first, right? 5 is the numerator that comes first before 1. So I'm not going to start with 1 times 3. I'm going to start with 5 times 2. So 5 times 2 is 10, and then 1 times 3 is 3, right? Then 10 minus 3, it will give you 7 over 6. Notice, if I had started with 1 times 3, it would have been 3, right? It would have been 3, and then 5 times 2 would have been 10. 3 minus 10 is minus 7 over 6, so it wouldn't be the same, you see. So that's why you start with the numerator that comes first. So this rule is going to apply in trig. You will see it in a moment, right? So first of all, what you do is that you just multiply the denominators, then after that you cross multiply the numerator. You'll say 5 times 2, which is 10, and then subtracted by 1 times 3, which is 3, and that gives you 7 over 6. So the rules for addition and subtraction are the same. So now you know how to add fractions, right? You know how to add fractions when the denominators are the same and when the denominators are not the same. Please remember this. Now I'm going to go to multiplication and division of fractions. Then we will go back to those stuff. Okay, so let's say we've got multiplication. The basic rule of multiplication is if you have something like a over b times c over d, you just multiply along the straight line. You just say a times c, which is ac, and b times d, which is bd, right? That's the basic rule. People hate fractions, but once you know how to add, subtract, multiply, and divide fractions, the fractions will just become like basic numbers, right? So you just multiply along the same line. You just multiply numerator with numerator and denominator with denominator. So we'll apply that here, but it will be correct. But my advice is, before multiplying, check if you can cancel some things, right? We call it cross multiplying, but when we say cross multiplying in this case, we're not saying we're really multiplying. What we're doing is we're canceling. Please remember that when you're multiplying fractions, the advice is that before you multiply along a straight line, check if things can cancel. Remember that before you multiply along a straight line, check if things can cancel. So what do I mean? So for instance, if you look at 3 and 15, you'll notice that the highest common factor is 3. So 3 into 3 is 1, and then 3 into 15 is 5, right? And then when we look at 10 and 2, the highest common factor is 2. So 2 into 2 is 1. 2 into 10 is 5. Now that we have cancelled, we can now multiply along a straight line. So this is going to be 5 times 5, which is 25. And 1 times 1, which is 1. So this is just 25. So this is multiplication of fractions. You can multiply along a straight line immediately, but my advice is cancel first before multiplying along a straight line. So that is multiplication of fractions. Here is another example. We can multiply and say 26 over 20 and simplify. It's still going to be correct, but my advice is let's just cancel first before multiplying along a straight line. So here's something. So here, notice the highest common factor is 2. It's just 2. 2 into 2 is 1. 2 into 2 is 1. Whenever something is the same but one is on top and one is down, they just cancel out. And then here there is no common factor. So we just multiply. 1 times 13 is 13, and 1 times 10 times 1 is 10. So that's what we have. Now let's talk about division of fractions. For instance, if you have something like 2 over 3 divided by, let's say, 4 over, let's just say 5, right? So when you are dividing fractions, the first fraction remains the same, and then the second one you switch. What I mean is that what is the denominator becomes the numerator, and the numerator becomes the denominator. So they just switch, right? That's all you do, right? You switch. Then from there you change the division sign into multiplication. Then we're back to multiplication. So we can of course multiply, but my advice is check if something can cancel. 2 into 2 is 1, 2 into 4 is 2, right? So then 1 times 5 is 5, and then 3 times 2 is 6. So that's what we have. So division, you change it. You switch the second fraction, then the division sign becomes multiplication. Then you are done. So here is another example. What you do when you have this. So 1 divided by, so now the main fraction is that longest line. So now we're going to say it's the same as 1 divided by 4 over 5. Then we just switch and make it multiplication. But my advice is, instead of just dividing, you can already switch. We know it's going to be, we can take 1 as though it's a fraction. So we can say a fraction divided by a fraction. So we know that the second one will change already. So the second one will change and it will become multiplication. So notice the numerator became the denominator and the denominator became the numerator. So we just change it and we make it multiplication, right? This you can look at it as 1 over 1, right? So then 1 times 5 is 5, 1 times 4 is 4. We will apply this in trigonometry. So it just becomes 5 over 4, right? So 5 over 4. Here is another example. We have 2 divided by 3 over 5. So we just say it's the same as 2 times 5 over 3, right? We just switch the second fraction. This 2, we can take it as 2 over 1, right? This 2 is the same as 2 over 1. So we can make it 2 over 1 divided by 3 over 5. I hope you understand that. So 2 over 1 divided by 3 over 5. It's the same thing, right? So if you just have a whole number divided by a fraction, you can make that whole number into a fraction. So then it's going to be 2 over 1 divided by 3 over 5, which becomes 2 over 1 times 5 over 3, right? Here's the last example. Then we go to trig. Now we've got 5 over 3 divided by 2. So what do we do in this case? This 2 is the same as 2 over 1. So we can say 5 over 3 divided by 2 over 1, but we already know it's gonna be times 1 over 2. So immediately you can even change it immediately from here. So when you see 5 over 3 divided by 2 over 1, you can say 5 over 3 times, then you switch the second fraction. Remember, the first fraction remains the same, the second one changes. So if you have something like that, if you have got maybe 5 over 2 divided by 3, the second whole number just becomes a fraction, right? So whatever whole number you have in a complex fraction, you make it a fraction, then you will be dealing with 2 fractions again. So memorize these basic rules. If you have not memorized it nicely, you can reverse the video and memorize it. Then yeah, then now you'll be able to deal with trig. So let's now go to trig. So they say prove the identity. So whenever we're proving the identity, we choose one side and we make it look like the other, right? So usually it's best to take the complicated side and make it simple than to take simple and make it complicated. So what do we do here? Whenever you see a fraction, you can never be stuck given those rules that we dealt with. Okay, what am I talking about? So for instance, because just one fraction appears, we can deal with the whole thing as though it's addition or subtraction of fractions. So in other words, you say this is one fraction, right? So the minute we have a fraction, you deal with it as addition or subtraction of fractions. If it's multiplication, then you deal with it as multiplication of fractions. So now because we have a fraction, we'll treat the other one as a fraction, right? So then this will become over 1. Then let's use the rules of adding fractions. So the denominators are not the same. So since the denominators are not the same, we know the rule will multiply. We use the butterfly method. We multiply. Then this sin x times 1 is just sin x. Then we cross, right? So we'll multiply 1 and 1. It just becomes 1. Then we have minus. Then sine and sine just becomes sine squared x. Easy, right? So we just multiply the denominators, then we cross multiply, right? That's just the rule of adding fractions. And then now here's the changing part of it, you see? So now we know that 1 minus sine squared is cos squared. So then this just becomes cos squared x over sine squared x. Okay, sine x, I mean. And notice, this is the same as the right-hand side. So we're done. So therefore, we can say equals to right-hand side, right? Then we're done. Let's go to the next example. Okay, here is another example. My advice is the minute you see tan in trigonometry, deal with it. Don't give it time. So we know tan is sine over cos. So then this is just going to be, okay. This is just the numbering. I hope you are aware that this is just a numbering. This does not play part of this. So then tan is sine over cos. Then this becomes 1 over sine over cos. Now, I hope you're aware that this is what I call a complex fraction. We're just from dealing with it. This is division of fractions. So whenever we have division of fractions, let's deal with it in the side. So I'm going to deal with it in the side here. So notice this is 1 divided by this. So we can treat this one, notice it's a whole number divided by a fraction. So we can treat this one and make it a fraction. And then divided by sine over cos is the same as times cos over sine. If you don't understand anything, comment on the section below and I will respond. So 1 over 1 times cos over sine, right? That's what we have. So notice, it's just simple, right? You just deal with it using the rule of division. So then this will become 1 times cos. You see, there's nothing to cancel, right? So we just multiply along the same line. So 1 times cos x is cos x. And then 1 times sine x is sine x. So the answer is cos x over sine x, meaning that this will become sine x over cos x plus cos x over sine x. That's what we have. Now we have addition of fractions again. Very simple. So this, we just use the rules of addition. Let me just continue here. So cos times sine, remember what we the denominators are not the same. So if the denominators are not the same, we multiply. What is cos x times sine x? It's just sine x cos x or cos x sine x, but it's preferable to write it in this order. And then from there we cross multiply. So sine x times sine x is sine squared x, then plus cos x times cos x is cos x squared, or cos squared x rather, cos squared x. And then do we notice something here? Sine x squared plus cos squared x is 1. That's why I gave you those things to memorize. So that's what it becomes. So then this will be exactly the same as the right hand side. So we're done. We say equals to right hand side. Alright, here is another example. We have cos x over 1 plus sine x plus tan x. They said we must prove that is equals to 1 over cos x. So it's best to take the complicated side and make it simple than to take the simple side and make it complicated. So what do we do in this case? So in this case, remember, whenever we see tan, we always deal with tan. So we're going to say equals to cos x over 1 plus sine x. Then we're going to say plus. So tan we know is sine x over cos x. So my advice is every time we see tan, we take it first. We don't give it time. Then when you have fractions adding or subtracting, even if it's a fraction and a whole number, whenever you just see a fraction and we'll talk about addition and subtraction, you can never be stuck. Use the rules of adding fractions. So notice, we're going to use the rules here. So then this just simply becomes, we're multiplying this stuff. My advice is not really to multiply, it's just to keep it in brackets. What do I mean? You see, if we have x times x plus y, we would keep it in bracket and just say x plus y. So we don't have to put x in bracket since it's one thing, but we'll put the other one in bracket since it composes of 2 terms. So that's what we do. This is 1 term, this is 2 terms, right? We have 2 things here, 1 thing here. So when you multiply, we'll just bring this in front, and what is more than 1 term, we'll just put it in bracket. That's all we do. That's all we do. So we just mix them. We're not gonna really multiply, we're just gonna put them together. The bigger one will be in bracket. What if you've got 2 things and 2 things? Then both of them will be in brackets. Like if you've got x plus y times x plus y, it's just gonna be x plus y times x plus y. It's just gonna be like that. Then after that, we now cross. So let's cross. So then this is gonna be cos squared x, and then this side is gonna be sine x times, you see, notice one thing multiplied by 2 things. So 1 times, okay, 1 plus sine x. So now we're gonna deal with the top. So now this is gonna be cos squared x plus Sine x times 1 is sine x, and then that becomes sine squared x all over cos squared, okay, cos x plus 1 sine x. So let me just rewrite this on top. Okay, so I've rewritten it. Alright, so now what you should notice is that we have cos squared and sine x over this side, right? So cos squared x plus sine squared x is 1, right? Just like sine squared x plus 4x, cos squared x is 1. 4 plus 6 is 10, just like 6 plus 4 is 10. Alright, so these two will add and give you 1, right? These two will give you 1. Or if you don't like this method, you can use another method. Another method is, notice this is cos, sine, sine. So they're not all speaking the same language. We can change this one to speak the same language as the others. So then you can change this cos squared to become 1 minus sine squared, right? So I'll do both methods. So let me use both methods. So on this side, I'm going to use this method. So cos squared x plus sine squared x is 1. Even if they're not close together, you should be able to see that they're 1. So then it just means it's going to be 1 plus sine x because we didn't add this one. And then at the bottom, we've got 1 plus sine x. Notice these two are exactly the same. So when something is the same, they cancel. So what are we left with on top? This whole thing cancels, right? So when something cancels in division, it does not leave a 0, it leaves a 1. So there we have it, the same as the right hand side. So let's just say you don't like this method. Okay, fine. So since we have got cos, sine, sine, we can change cos to speak like sine also. So cos squared is the same as 1 minus sine squared x. And then now we're just going to rewrite those ones that we did not change. And then plus sine squared x. Okay, then you will notice, then this is okay. Of course, this is over cos x and then 1 plus sine x. So all I did was just to change this into 1 minus sine squared x, right? 1 minus sine squared x. So notice, this and this are like terms. And if you have got minus x plus x, let's just say, let me write it here. If you've got minus x plus x, they just cancel out. So it's the same thing we're going to do there. Because notice we've got minus sine squared and we've got sine squared. So they two cancel. And then now we're going to be left with exactly 1 plus sine x over cos x. Then we have the same thing. They cancel. It gives you 1 over cos x. It gives you 1 not because of this one. This whole thing cancels with this whole thing. But when something cancels and leaves nothing, there is an invisible one. So that's what we have. And again, this is the same as the right hand side. It's the same as the right hand side. Okay, here is another one. So they say prove the identity, right? Prove the identity, and you are given this stuff. So of course, we see fractions adding and there's no tan, so we don't have to deal with tan first. In this case, because there's no tan. But now we see addition of fractions. You can never be stuck when fractions are adding. So you can even try. Let me see. Maybe you can pause the video and just try it and play. And let's just see. Okay, so this then is addition of fractions. We multiply these two. So my advice is, for now, don't yet fully distribute it. For now, we'll just keep it like that. We might distribute it, but we'll leave it like that for now. So we multiply. Remember when I say it's two things and two things, it's just going to become this type of bracket. Then from there, you just multiply this 1 times this whole thing is just that whole thing, right? And then now we have plus 1 times this thing is just that thing. And then notice we've got like terms, sine and sine. Now it's the same as x minus x if we rearrange it. So this 2 goes out. And then we'll be left with 1 plus 1. 1 plus 1 is 2. So we literally have 2 over 1 minus sine x and 1 plus sine x. So we just have this thing. So how do we go forward? Notice the 2 is the same as that, so it means we have to change the bottom. Now notice this bracket, you just have to multiply using grade 10 algebra, right? You just distribute. When you distribute, we are going to be left with 2 over, we're literally going to be left with 1 minus sine squared x, right? That's what we're going to be left with, 1 minus sine squared x. And we know that 1 minus sine squared x is cos squared x. So then this just becomes 2 over cos squared x, which is the same as the right hand side. So in trigonometry, you can never be stuck when we talk about adding fractions. If you see fractions, you just add them. Here is another one. So we have got tan x squared, or tan squared x minus 1 over cos squared x. And here they didn't tell us to prove the identity, they just tell us to simplify. So when we simplify, we have to make it one trigonometric ratio. So what do we do here? Very simple. We see tan, we have to take tan first. So then this is going to be sine squared x over cos squared x minus 1 over cos squared x. And notice we have the same denominators. Whenever we have the same denominators, we don't have to multiply, and that it will be a long cut. We can still do that, but it will be a long cut. Same denominators, we just delete the numerator on it. So same denominator, the denominator will stay the same, right? The denominator will stay the same, so it will just become cos squared x. And then what do? We cross multiply. So what is sine squared times cos squared? So sine, okay, no, we don't cross multiply. I made a mistake there, right? So remember, same denominators, we just deal with the numerators, we just add the numerators, right? So, or we subtract the numerator because it's subtraction this time. So same denominators, we just deal with the numerator. So in this case, we know 1 minus sine squared. We don't know sine squared minus 1. There's two methods we can use here, right? The first method is to rearrange them, but when you rearrange them, you have to take it together with the sign. So I'll do two methods. The other method is just to change, right? So let me do both of them. If we rearrange them, this becomes minus 1 plus sine squared x over cos squared x. But we know 1 minus sine. We don't know minus 1 plus sine. So here, what do? What we can do is that we can factorize -1. If I remove -1, -1 divided by -1 is 1. Sine squared divided by -1 is negative sine squared. I'm still going to use another method, so if you don't like this method, we will use another method. So now notice 1 minus sine is cos, 1 minus sine squared is cos squared. So then this becomes minus 1 times cos squared over cos squared. Well, this is just the same, so they cancel out, and the answer is minus 1. So what then? The answer is minus 1. So let me use another method. Let's just say you don't like this method. But this method is simple. You just rearrange them, and the signs are not what we want. So we just factorize -1, and then we divide to obtain what should be in the bracket. Yeah. So if you don't like this method, let me use another method. Well, the other method is simple. Sine squared is the same as 1 minus cos squared, right? And then we have minus 1 there, and then we have got cos squared x. So 1 minus 1, it goes out, right? It leaves that. So now we're left with minus cos squared x over cos squared x. This cancels and leaves -1. Okay, here is another one. So now we have this stuff, right? So the minute we see fractions, it's still diluted as additional fractions. But notice now we've got three things. So it means it's going to be sine over 1 and cos over 1. So what do we do here? Let me show you how to add three fractions. Others can choose to add the first two, and then the results can be added to this one. But let me just show you. Let me extend the method now for three fractions. So what do we do when we're adding three fractions? Let's just say we've got maybe 2 over 3 plus 4 over 5, and let's just say plus 2 over, let's just say 7. When we're dealing with three fractions, we do the same thing. We'll multiply all the denominators. So 3 times 5 is 15. 15 times 7 should be 1 over 5. So if you can verify that. And then before we would cross multiply, but now here we've got three things. How are we going to do it? It's very simple. When we come to each numerator, we will multiply every denominator except its own one. For instance, we're going to say 2 times 5 times 7. You see, I didn't count its own one. So 2 times 5 times 7. 2 times 5 is 10, times 7 is 70. Then we come to 4. Now we'll multiply with all the denominators except its own one. So 4 times 3 times 7. Notice I didn't say times 5. 4 times 3 is 12. 12 times 7 should be 84. So 84, right? Then now we're going to say 2 times everything except its own denominator. So 2 times 3 times 5. So 2 times 3 is 6 times 5 is 30. And then we just add all this stuff and then over 1/2. So that's what we do with three fractions. We just multiply all the denominators. Then when we come to the numerators, we'll just multiply the numerators by every denominator except its own one, right? So we just do that for each. So we are going to apply that here. So now we'll just multiply. So 1 times this thing times 1 is just this thing. So it's going to be that. So now we're going to say sine times this except its own one. So sine times this stuff, because it's just 1. 1 has got no effect. And then we're going to say 1 times 1 times 1. So this is a minus, so we put minus. So 1 times 1 times 1 except its own one, just 1. Cos times this except its own one is now cos times that stuff. So then we're going to have plus cos times that stuff. And then from there, now we're going to distribute. So let's distribute. So if we distribute, we're going to have sine squared x plus sine times cos is just sine cos. So sine x cos x. And then minus 1. And then from there, we distribute also that one. Cos times sine is just sine cos. So, or cos sine is just the same. So then it's going to be sine x cos x. And then cos times cos is cos squared. So then we have over sine x cos x. So sine x times cos x. So this is what we have. And then now when we say sine squared plus cos squared, that is 1, right? You should be able to see it even they're not close to each other. So sine squared plus cos squared is 1. So this stuff gives you 1. So then this becomes 1 plus sine x. Okay, sine x cos x plus sine x cos x is the same as xy plus xy, which is 2xy. So then this becomes 2 sine x cos x, right? Minus 1. So this minus 1, we haven't done anything with it. So sine squared plus cos squared is 1. Then sine cos plus sine cos is 2 sine cos. And of course, we have over sine x plus cos x. And then now notice this and this cancels out. Then at the end of the day, we're left with sine x cos x over sine x plus cos x, which is exactly equals to the right hand side. So if you enjoyed this video, please like my video and subscribe to my channel. And you want to tutoring sessions, please WhatsApp according to what I advertise there.